Hello and welcome back to elementary algebra. We are talking about factoring of trinomials, which is section 6.2, and we are dealing with a special type of trinomials which have x squared term have a coefficient of 1. So this would be 6.2 would look like this, let's say, and then 6.3 would look like this. I don't know, whatever. So we are focusing on the ones where the front coefficient is 1. Now we don't write it, so it's just x squared. Now 6.3 is actually intermediate algebra, so we will not be covering 6.3 anyway in the class, but I just wanted to make sure that you know that when you have anything in here other than 1, it's either going to be factoring by, greatest common factor, or it's going to be 6.3. So that's what we are focusing on. We're focusing on problems which have this, and we know that the answer for something like this is supposed to be, these two binomials with x plus some number here in the box and x plus some other number here in the box. Now, the question is, right, can we figure out what numbers go there and so on? Now I notice that this problem is actually backwards. In order for us to solve it, this needs to be 4, this needs to be 3 in order for it to work out. And maybe you can guess these numbers, but we're going to have this really cool systematic way to do these problems. And if you are not lazy, you will get these problems every time correctly. Obviously, if you try to cut corners and so on, you might get them wrong. So let's take a look at the procedure on how these things are solved. So let's say you go back to chapter 5 and you have your x plus, let's say 1 times x plus 3. What would it multiply into when you FOIL? So how much is x times x?
X squared.
Thank you. And then x times 3 is?
3x.
Beautiful. 1 times x?
X.
And 1 times 3?
3.
And now do we see that we have to add the middle terms here? So it works out to be 4x plus 3. Oh, that means that these numbers here are 1 and 3. So what we are doing now in chapter 6 is chapter 5 backwards. You used to multiply in chapter 5, monomials, binomials, whatever you were multiplying. Now, your job is to break those apart into factors. And the reason why we're doing this is we need that so we can solve equations. Now, equations model the world around us, so we need to be able to solve equations. So some equations will have this type of solution where you have to factor, and when you factor, you will eventually be able to solve. Now that's going to be at the end of the chapter when we solve equations with these. Now we're only focusing on figuring out these factors. So what I said in a previous class is that when you have a times b equals c, these guys are called factors, and this guy over here is called a product. Now, same thing goes for these. If you have, let's say, x plus 3 times x minus, I don't know, 10, whatever, the answer over here would be, and I know the shortcut so I can write answer immediately. This needs to be, there we go. So the answer over here would be x squared minus 7x minus 30. Now, remember, see what I did? I skipped this middle middle part at all, right? Completely. Now, first and the last are easy to see, right? Because you have x times x is x squared and 1 times 3 is 3. In my case, x times x is x squared. 3 times negative 10 is negative 30. Easy, right? The middle term is the one that, right, we had to add in this case over here. We had to add 3x to x to get 4x. Now, I wrote immediately negative 7. How did I know immediately negative 7? Well, plus 3 minus 10 is negative 7. So this is actually going to also up your game for multiplication of these polynomials, because you will be now able to multiply faster knowing that simply adding these two numbers at the end is providing you with this middle value here of negative 7. Now, how does that help us with factoring, which we want to do today? So factoring of x squared plus bx plus c. All right, so here's the way it goes. Need to find two numbers, call them m and n, such that, number one, they multiply into to get c, they add to get b. So in shorthand, right, m times n needs to be c, and m plus n needs to be b. So if I can find two numbers where that's the case, I can write my x squared plus bx plus c is going to be x plus m, x plus n. Now, this sounds like a lot of work and a lot of words and a lot of thinking, but when you try it on a problem, it turns out to be a joke. And we're going to try it on our problem here, which is this x squared plus 4x plus 3. No. So, x squared plus 4x plus 3. And here is the part where I said, if you are not lazy, the life is going to be a joke here. Make the chart of all pairs that multiply into a 3. Now it's just 1 and 3, so not much to do there. But you will have, 3, 4, or 5 of these rows. So once I wrote factors of 3, which is 1 times 3 is 3, then I see what they add into, and they add into 4. So both of the conditions are satisfied. 1 times 3 is 3, and 3 is your C, right? And 1 plus 3 is 4, which is B. So we immediately found a value, right, of two values, two numbers, that work. So this factors into x plus 1, x plus 3. And you can verify that by multiplication. Now let's find some nicer examples to actually see this in better. So let's say x squared plus 7x plus 12. This is a much better example. Always the same step. So don't be lazy, and it's going to work great. Here's your 12, and here are all of the factors of 12. 1 times 12 makes 12. 2 times 6 makes 12. 3 times 4 makes 12. 4 times 3, oh, I already have 3 and 4. Okay, I'm done. This is how you know that your list is done, because the numbers that are factors start to repeat. See, I start always with 1, then go with 2 and 3. If I have to skip some because it's not divisible, I skip them. But then the next number after 3 is 4. And to make a 12, I need to multiply by 3. Now, whether you say 3 times 4 or 4 times 3, it's the same numbers. So that's why we don't have to go any further other than these three numbers. Now, all you need to do, and this is the part where I say if you're not lazy, you are always successful here. All you need to do is to look at this and say 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. Aha, 7. That's what I'm looking for. So the numbers are x plus 3 and x plus 4. Those are my numbers because that's the row that added to 7, which is what I need. So each one of these rows is multiplying into 12. So they are all satisfying condition m times n equals c. M times n equals 12 in this case. But only one of these rows satisfies condition m plus n equals 7. And that's this last row. So it's very systematic, insanely easy, but only if you are able to create the chart of factors and then you go from there. Let's take a look at one more of these from the book, and then I'll give you a couple as well. So here is the another one from the book, x squared plus 13x plus 30. Okay, I immediately go and I make my list for factors of 30. 1 and 30, 2 and 15, 3 and 10, 4, I'm going to skip 4. 30 is not divisible by 4. So I skip 4. And then 5. 30 divided by 5 is 6. The next number here would be 6. I already have the 6, so we're done. Now, what do these numbers add to? This one's add to 31. This one adds to 17. This one adds to 13. Ding, 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 ding. There we go. X plus 3, x plus 10. The bottom one adds to 11, but who cares? So we were able to find, again, the sum. So multiplication into 30, multiplication into C, gives you a couple of choices, and then you narrow it down to the one that you need when you add them across. So you always have to have m times n equals 30 in this case, and m plus n equals to 13 in this case. So all four of these are satisfying the first one because they're all factors of 30. But then only this one here is working out for the second condition because 3 plus 10 is 13. And that's it. Once you satisfied both conditions, those are the ones that you have to use. All right, so time for you to show off your math skills. So I'm going to pick, 2-3 exercises from the book for you to try. So let's go with, doesn't matter whether it's m or x or whatever. So here is the, plus 36. So you need to come up with the factors of 36 and see if any of those add to 13. All right, go. Always start 1, 2, 3, 4, 5 and skip those that do not divide. Let me know if you are done.
I think I'm done.
So what are the two numbers that you picked at the end?
9 and 4.
9 times 4 is 36. 9 plus 4 is 13. Perfect. That's exactly what it is. All right, let's find those numbers. So 36 divided by 1 is 36. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 divided by 5 doesn't work. 36 divided by 6 is 6. And this is the end of the list, right? You can't, if you go, these are the same numbers. So when you get the numbers to be close or same like this, that's it. 7 doesn't work, 8 doesn't work, the next one is 9, and we already have a 9. So these are the 5 pairs of numbers that could be possibly our answer. Well, only one of them adds to 13. That's 4 plus 9. So whether you're going to write m plus 4 or m plus 9 first, it doesn't matter. You just need to write both of them in whatever order. That's it. We move on. So as I said, if you write this chart, these problems are a joke, and it should always take less than 2 minutes. You are not always guaranteed for this to work out, so be careful. If nothing on a list works, make sure that you have all of the pairs, which is why we go in order. Divide by 1, divide by 2, divide by 3, divide by 4, divide by 5, divide by 6. And you are probably not going to miss anything if you go and make your list in order like that. So I'm going to now put n squared plus 52n, again this is from the book, plus 100. So get the factors for 100, see what adds to 52.
I got it.
Okay, so what do you have as answers?
N plus 2 and n plus 50.
Excellent. Now, sometimes when you go through the list, if you hit the number that you see that it works, you can just stop with the list because only one pair in the list can work. So when you start, there we go. Woo! So when you start dividing, you go 1 divided into 100 gives 100. 2 divided into 100 gives 50. Oh wait, that adds to 52. I really don't have to go through the rest. Now you can skip 3, 4 into 100 goes 25 times, 5 goes 20 times, 6, 7, 8, none of that stuff works, and you get up to 10. So you can go and do the entire chart, but if sometimes, it's very easy to immediately see what works, and you just get those, and you don't even have to finish the chart, right? That's something that is cool. Now, let's put some minus signs in the mix, right? All of the problems we did so far only had addition. When you start using minus signs, then minus signs need to show up in your factor or table of factors or chart, whatever. So how about if you have a problem, let's see something, again, introductory. We're not going to go with complicated stuff. Let's go with x squared minus 8x plus 15. So now we have a negative sign. Nothing changes, guys. You still have to find factors of 15. And those are 1 and 15, 3 and 5, and then nothing else works. That's it. Those are the two pairs. Now, you're supposed to add them into a negative 8. Now, if you go 3 plus 5, that gives you positive 8, so no bueno, right? Now, this is the time where you have to remember that negative times negative is also a positive. So, we actually have now negative 3 plus negative 5, and that does give negative 8. Yay. So hopefully you understand, right, that positive times positive gives positive, and then negative times negative also gives positive. So when you have negative signs around, you have to figure out whether these values in a chart should stay positive or turn negative. So when the sign for C is positive 15, your signs in the chart have to be the same, both positive or both negative. And then this one obviously over here will dictate whether you need those negatives or not. So I just want to present another example. This is a great one. So x squared minus 7x plus 10 versus x squared plus 7x plus 10. So both of these will have the same chart because they're both factors of 10. So 1 and 10, 2 and 5, and literally nothing else divides 10. Over here I also have 10. It's 1 and 10, and 2 and 5. Now I already see that these are my solutions on the right side. These are the old problems because 2 plus 5 is 7. So I have my x plus 2, x plus 5, and I am done. I can check that. X times x is x squared, x times 5 is 10 at the end, and then I have 2x and 5x to add into 7x. On the left, they do not add into negative 7 until I change all of the signs into negatives. Because again, negative 2 times negative 5 is positive 10. So you see that this is actually the same problem, and the answers are just flipped like this, right? The answers are flipped. So one is x minus 2, x minus 5. The other one is x plus 2, x plus 5. So we have to be a little bit careful about those. So let's take a look at more of these problems. Now they give some kind of chart of things to memorize. You don't have to memorize any of that stuff if you are using this factor chart that I just showed you. All right, so try y squared minus 12y plus 27.
I think I have the answer.
Okay. So what
What?
do you think are the values?
3 and 9.
3 and 9?
-3 and 9.
No, I was just giving the numbers, the two numbers.
Oh, okay.
Yeah,
But
no.
it's,
I didn't give the.
yeah, but it is negative.
I know.
Oh, okay, good.
I
So
thought you
as
just.
long as that makes sense, then we can move along. So we have a 27 over here, and that's going to factor into 1 and 27. 2 doesn't divide. 3 and 9, and we already see the 12, so that's yay. 4, 5, 6, nothing else works. Now, since I need negatives there, both of these need to be negative, and I have y minus 3 and y minus 9. So this chart makes it a joke, right? It's a cool thing. All right, z squared minus 13z plus 40.
I have z -5 and z -8.
Negative, you said what? Negative?
-5 and -8.
Excellent. So 40 will be broken into 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8. Oh, those are the negative ones, right? And there we go. So z -5 and z minus 8. Great. So far we have seen two of these worlds where the number at the end is positive, and when that number at the end, C, is positive, your chart works out to be the chart of positive values or chart of negative values, and you go and simply just write out the solution. So that is not, right, that is not a problem. We have figured out how to do this thing. Now, the question is, what happens when the last number, that c, is negative? In this is a trickier case because your numbers now in the chart is one has to be negative, one has to be positive. And let me illustrate that with an example. So let's say you have x squared minus 2x minus 24. So let's say this is your problem. Now your factor needs to be negative 24. Now, you know that 1 and 24 and 2 and 12 and 3 and 8, 4 and 6, 5 doesn't work, and then 6 is already there. So these are our numbers. But it needs to be negative, which means one of these, 1, must be negative. And that's because 24 is negative. Only way to get a negative in multiplication is to multiply positive with a negative. So you go and you say, all right, how do I get negative 2 now? Well, that's going to be a subtraction. And the only way to get it from these numbers, right, you can go 1 minus 24 and you get negative 23, or 24 minus 1 and get positive 23. You can go 2 minus 12 and get negative 10, or you can go 12 minus 2 and get positive 10. You can do 3 minus 8, get negative 5, or 8 minus 3 and get positive 5. And here is the $1 million move. 4 minus 6 is negative 2. 4 minus 6. Positive 4, negative 6. Okay. So when you have the chart written and you are looking at it, the rest of the problem is supposed to be a living joke. All right? You can see how many combinations are there. You actually have 8 possibilities here coming out from the 4 rows in the chart. It's not fun to keep all of that in the head, trying to solve the problem. So the hope is that you guys will always do the chart and then use it to quickly come up with the answer. X squared plus 7x minus 8. So factor out minus 8. That's 1 and 8, 2 and 4, 3 doesn't work, and 4 I already have. So that's it. How do I make positive 7 out of these numbers? You tell me.
Positive 8 and negative 1.
Excellent. Positive 8 minus 1 will give me positive 7. So x plus 8, x minus 1. This is very visual, and it's only easy if you're not lazy. That's all it is. Plain simple as that. Let's take a look at some of the homework problems. So here is the one for you. X squared plus 15x minus 100. This is given as a problem 44 on the homework. So go ahead.
I have a quick question that's a little off topic. Did we get the homework for 6.1 because it wasn't showing up on?
Oh, okay. I'll fix that.
Yeah, because I haven't seen any homework since 5.4.
Yeah, I'll fix that.
Okay, thank
Yeah. So make the factors. Any luck with numbers?
Yes, it's x minus 5 and x plus 20.
Excellent. Yes. So those are, right, those two are correct answers. Again, the way we do this is we go and figure out the chart first, and once you have the chart, you just go and solve it. So negative 100 breaks down into 1 and 100, 2 and 50, 3 doesn't work, 4 and 25, 5 and 20, and 10 and 10. Is there a way to make 15? Well, the only one that could make 15 are these two, and we'll get that with a positive 20 and negative 5. So x minus 5, x plus 20. Now let's see another problem, and this one, let's go with b squared minus b minus 20. What are my numbers?
1 and 20, 2 and 10, 4 and 5, and then 5 and 4, I guess.
It's well, 5 and 4 would be a repeat, so we'll keep it
Yeah.
up. Great. Is there any way to make up a -1 out of these numbers? Can we make -1 with any of these combinations?
You can do -5 and +4.
-5 and +4. Correct. +4, -5 is going to give us -1. Awesome. B plus 4, B minus 5. Now, let's see. Y squared minus 15y minus 34. So what are the numbers in the chart?
1 and 34, 2 and 17.
Anything else? Well, we don't need actually anything else
Yeah.
because we already found it. How do 2 and 17 make -15?
-17, +2.
Yes. So +2 minus 17 will give us -15. Y plus 2, y minus 15. There it is. All right. X squared plus 5x minus 4.
It's 1 and 4.
1 and 4. Let's check. So -4 and 1 and 4. and 2 and 2, right? Those are the only ones. So I need one to be positive, one to be negative, and I need to add into positive 5. So if I have negative 1 plus 4, that will add to 3. And if I have 1 minus 4, that will add to negative 3. So we can't use these two numbers because none of them gives me plus 5. Now we'll try with 2's. Negative 2 plus 2 is 0. 2's do not work. Cannot factor. So this negative 4 on top is asking you to have one number positive, one number negative. So I understand that 1 plus 4 is equal to 5, but neither of those is negative, and that's a problem. Because when you multiply 1 times 4, you get positive 4, and you need negative 4. So this problem is not factorable because of that, and we call them prime. They are called prime because they cannot be factored. Just like numbers, like number 13 is prime because it cannot be factored into, it cannot be factored, so it's called prime. Number 8 is not prime because 8 could be written as 2 times 4. 15 is not prime, 3 times 5, right? But number 7 is prime, 13, 11, right? A lot of these numbers, well, there are infinitely many of prime numbers out there, but you have this idea of same for polynomials. So whatever cannot be factored, we say it's prime. And again, the only time you know that something is not factorable is because you just can't make these things work. You can't make signs work out. So let's see. The problems that I'm placing from now on, I don't know if they're prime or not prime. I'll just, put them out there and then see what happens. So 63 uses z's. I'm going to switch to x's because I can. So x squared minus 5z minus 66. So factors for negative 66. Let's see what you get. Any luck with the problem? What are the numbers in the list? Hello? Wake up.
It is 1 and 66,
Perfect.
2 and 33, 6 and 11.
Well, we have 3 and 22.
Oops.
Yep, that's okay. 3 and 22, 4 doesn't work, 5 doesn't work, and 6 and 11. Okay. Now, would any of these make a 5? Negative 5? Is there a way to make a negative 5 anywhere?
Is it negative 6 plus 11?
Negative 6 plus 11 will give me positive 5. I need a negative 5.
Oh, I'm sorry. Okay.
So how do we fix it?
Six minus 11.
Excellent. Yes. So 6 minus 11 will give us negative 5. And now 1 is positive, 1 is negative, exactly what we need for that negative sign. And we just write x plus 6. Oh, sorry. Oh, I have x and z's mixed up. X. So x squared minus 5x minus 66. Okay, so x plus 6 and x minus 11. Well, perfect. Now we're going to have 2x squared plus 8x minus 10. Now, who remembers what I said in the beginning of the class about this?
I was late to class. Can you repeat what you told us about?
Okay. So what I said was that we are, if we are only factoring in elementary algebra, we are only factoring when the front coefficient is 1. And if this is not a 1, then it's either going to be a GCF problem or it's going to be intermediate algebra factoring, because 6.3 is in intermediate algebra, it's not in our class. So now that I said that, right, we have to use the GCF first, meaning we are going to see that GCF is 2, which is what we learned last class. Kick that out, have x squared plus 4x minus 5. And now worry about, well, it's just 1 and 5 in this case. And to make a positive 4, we need 5 minus 1, which is, so 5 plus 5 and x minus 1. So these problems now are going to bring in an extra step in factoring, because you have to get the extra step in factoring, because you have to worry about the GCF as well. So there's that part. Does it make sense?
Yes.
Awesome. So now negative 3m squared minus 9m plus 12 is another one of these where we have to do the GCF. So what would be the GCF?
-3.
It will be a -3. Good. So when I kick -3 out, it's left with m squared plus 3m and minus 4. And now we just have our standard factoring, trying to figure out what two numbers would work out. The best, since we need 3, looks like 4 minus 1 will do it. So m plus 4 and m minus 1. So let's together, well, I'm going to give you one of these to try on your own. Let's say you have, this is good, negative y cubed plus 9y squared minus 14y. It's problem 72. Plus 9 squared minus 14y. All right, cool. So let's see what you get here. What is the GCF? At least we can start there. Anyone? I guess the GCF is not going well, right? It's a negative y. Each one of these has a y. You see a y. There are two y's in here. There are three y's in here. So the most I can kick out is a single y. And then we also need to get rid of the negative in front. So when I do that, put negative y in front, the leftover is y squared minus 9y plus 14. Let's see if that makes sense. If you guys have questions about this, you need to ask right away, because it just gets more complicated later. And if anything is unclear now, when our beginning stages, later all of this is going to become a part of a bigger problem, right? Of a problem of solving equations where you have to use factoring as a step. And if factoring obviously is not clear, then you're not answering factoring questions, and you are not answering all other questions later on that depend on factoring. So it's never like, okay, if I just miss one concept, it's not a big deal, because a lot of the mathematics later builds on this concept. So that's why it's important to know each one of these parts. So once we do the GCF here, which is always something that we would try to focus on first, then we can go and find factors of 14 as 1 and 14, 2 and 7, and then both of them being negative to make that negative 9. So ask a question if you don't understand any of this, any part of this.
When we're writing out our answer for this, and we get to the end part where it's like y minus 2, y minus 4, do we put the greatest, the GCF in front of it when we're done?
Yes, it's one of the factors, yes. So it has to be done, every time. So your GCF goes in front, and then the other two factors go in the back. All right, cool. So let's do one more of the GCF problems, and then I hope you will practice this a lot during the homework, and then bring your questions next class if these things do not work well for you. Let's say we have 4y cubed plus 20y squared minus 32y. So let's say this is our problem. Let's see. Can anyone tell me what the GCF is?
4y.
Excellent. All right, let's see if that helps for everyone to solve the problem. What are the leftovers when I pull out 4y?
Oh, you get y squared plus 5y minus 8. And then you
Excellent.
can't factor it, right?
Okay, let's take a look. So you claim can't factor. That's a possibility. So we have this one, and yeah, there's no way to make 5. Excellent. So it's factored because you have a factor of 4y and this. However, the trinomial is prime, so we cannot factor any further. We are technically stuck with what we have because that's it. Okay, great. So these are the basics, right, of factoring trinomials. 6.3 is going to be in intermediate algebra, so we're skipping that one. And when we come back after the short break, we are going to go through 6.4, which are those special factoring formulas that we learned in chapter 5. And now we're just going to do the same formulas just backwards. So let's take a short break, and then when we come back, 6.4. We only do actually half of that one because the other half is from intermediate. I'll explain.